Our objectives today are to learn how to write scientific notation into standard form, and then we'll learn how to compare expressions given to us in scientific notation to order them from least to greatest and vice versa. Let's get started on the first problem. Problem number 1 has the expression 5.2 times 10 squared. Now we know that 10 squared is equivalent to 100. So this is the same as writing 5.2 times 100, which would equal 520. In the second expression, we have 6.4 times 10 cubed, which is 1,000. So 6.4 times 1,000 in this problem would be 6,400. Now let's just take note of a little pattern here. When we multiplied by 10 squared, we moved the decimal 2 places in the problem. When we multiplied by 10 to the power of 3, we moved the decimal 3 places in the problem. What do you think is going to happen when we multiply by 10 to the 4th or 10 to the 5th? We can use our observation from the first two problems that the exponent told us how many places we would move the decimal point and apply that into the other problems that we have. This will save us time from writing out an expanded or product form like this. So in the first problem here, we have 7.8 times 10 to the 4th. We know that the exponent will tell us that we're going to move the decimal 4 times. So we're going to move it once past the 8, and then 3 more times for a total of 4. And we'll add in the spaces with zeros. So in this problem, our answer is 78,000. With 3.14 times 10 to the 5th, we're going to move the decimal 5 times. So we have to move it twice just to get past the 1 and the 4. And then we're going to move it 3 more times, so that's 3 more zeros on the end. And that's where our decimal will end up. And we end up with 314,000. So this is a little shortcut that we can take when we're writing scientific notation into standard form. We'll now turn our attention to scientific notation problems that have negative exponents. 10 to the negative second is 100th. So 5 times 10 to the negative second is equivalent to 5 times 0.01, which results in an answer of 500ths. Let's look at what happened here. So our original number, our original coefficient was 5. This guy here. When we multiplied by 100ths, we ended up moving the decimal point twice. Once to get past the 5, and then 1 more time, resulting in the 500ths. So the negative 2 told us that A would have a decimal as the answer, and that we would have to move the decimal point 2 times. Once past the 5, and then 1 more time, and then we could put our decimal in. We can use that shortcut to simplify other problems into standard form. In the next problem, we're given 7 1/10 times 10 to the negative 4th. As a decimal, 10 to the negative 4th is 1/10,000th. Now when we multiply those together, we'll see on the calculator that we get 71 10,000ths. Now let's look to see what happened with the decimal. The exponent of negative 4 told us that we had to take this decimal here in the 7.1, and we moved it 4 times to the left to create that decimal answer in standard form. So we moved it once to get past the 7, and then 3 more times. So we can say that the negative exponents work pretty much the same as the positive exponents. The exponent will tell us how many times we're going to move that decimal point. Let's use what we learned in the previous problem and apply it to the rest of them. So in the next problem, 1 and 25 hundredths times 10 to the negative 6, we have that negative 6 of an exponent. And that's telling us that we're going to move the decimal point 6 places to the left. So we're going to move it once to get past the 1, and then 5 more times. And there's our final answer. It's a really big decimal. We can go ahead and do the same thing for the remaining problems. Here was our coefficient of 2.4. Now we have an exponent of negative 3. So we're going to move that decimal point 3 places to the left. So we move it once to get past the 2, and then 2 more times, right in our decimal point, and there's our result. And again, we have a negative 4 as an exponent in the last problem. So we're going to move the decimal point 4 places to the left. 1, 2, 3, 4, decimal, and there's our result. So that concludes the first part of our lesson. We've learned how to take an expression in scientific notation and write it into standard form. Now let's look at ways to compare expressions in scientific notation, determine least to greatest values. The instructions are asking us to compare and order the values that are in scientific notation from least to greatest. There are a couple ways that we can do this. One of them is a little tedious and takes a little while longer. Let's look at that first, and then we'll look for a shortcut to be able to do this. So what I've done here is I took what we learned in the first set of problems about writing scientific notation into standard form, and I rewrote each value, each scientific expression into that standard form. So we can see here that we have some really large numbers. We have 48 million, 86 million, and we have 26,500,000. Once they're in standard form, it's fairly easy to see which one's smallest and which one's largest. So our smallest one is obviously the 2.65 times 10 to the 7th. Then it would be 4.8 times 10 to the 7th, and 8.6 times 10 to the 7th. Now, that's a last resort type option that we want to do for this. There's a much easier way, but it involves us using our observation skills to do this. So here's how I could have done this problem much quicker. When I look at the original problems given to us, the 4.8 times 10 to the 7th, the 8.6 times 10 to the 7th, and 2.65 times 10 to the 7th. What's obvious here is that the powers of 10 are the same in each problem. So if the powers of 10 are the same value, all we have to do is look at the coefficients, 4.8, 8.6, and 2.65. I can just order these based on the coefficients. So we can see 2.65 is less than 4.8 and 8.6. So I would start with my least greatest right here. That's the least. And then this one would be the greatest. So use your observation skills. First, check the powers of 10. And if they're the same, you can order them based on their coefficients. Now let's look at what happens if we have different coefficients and powers of 10. In the next set of problems, we're again asked to order the values from least to greatest. So using my observation skills, I see that between the three expressions, the coefficients are the same. The coefficients are all 3.36. What's different about these, though, is the powers of 10. I have 10 to the third, 10 to the negative third, and 10 to the fifth. I know that 10 to the negative third would represent a decimal value in standard form. The other two powers of 10 have positive exponents, so they're greater than 1. They're not decimals. Right away, I know that 3.36 times 10 to the negative third is the smallest. This is the least greatest. Now I've got to order 3.36 times 10 to the third and 3.36 times 10 to the fifth. Well, 10 to the third is smaller than 10 to the fifth. So that means that 3.36 times 10 to the third would be next, and the largest value is 3.36 times 10 to the fifth. So there you have it. That's a real simple way to order these from least to greatest. We didn't have to convert anything to standard form. We could just look at these and use number sense and our observation skills to order them. In our final set of problems, we're given 3 more expressions in scientific notation that we need to order from least to greatest. This time, though, all of the powers of 10 have negative exponents. So I'm going to start with the powers of 10. We have 10 to the negative 6, 10 to the negative 6, and 10 to the negative second. The key here to remember is that negative 2 is greater than negative 6, right? If we were to look on a number line, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, we can see negative 2 is a greater value than negative 6, right? And the number line increases as we move to the right. So that's a really important thing to pay attention to when we're doing this. So in terms of the largest, right away, we know that 8.99 times 10 to the negative second power is the largest. That means we now have to decide between 1.99 and 8.99 times 10 to the negative 6. Because the powers of 10 are the same, we can just use the coefficients. And in this case, 1.99 is smaller, so that's going to be our least value. 8.99 is larger, and there you have it. Those are our expressions ordered from least to greatest.